So this is the second video in a two-part series on database scaling. In the first video, we covered how to deploy MySQL in a master-slave configuration that spanned multiple AZs. That solution worked perfectly fine, but today we're going to explore some of Amazon's kind of native offerings for a fully managed solution. So let's get at it. So just to recap where we were, this is where we ended the last time. So we deployed 2 additional compute resources, one in one AZ, one in the other AZ, and on those we installed MySQL and we configured them for kind of a master-slave configuration. So we still want to have that 2-tier deployment, but now instead of exploring us deploying compute resources and managing those resources and managing the version of MySQL and all the security associated with those, we are going to deploy one of Amazon's RDS solution. So there's 2 solutions from Amazon that are compatible with our MySQL instance. One, they have a MySQL version of RDS, and then they also have an Aurora version. So we'll look at both of those. So this is where we want to end up today. We want to have a multi-AZ deployment of Amazon RDS, whether it's the Aurora version or the MySQL version. Okay, so let's go ahead and look at our create options. So we're going to create the database. And we're going to explore both of these options. I'm going to explore the MySQL first, and we're not really going to deploy it, but then we'll deploy an Aurora equivalent. When you select MySQL, you're going to get some options to choose the version of MySQL that you want. And then this is one of the biggest differences here between Aurora and MySQL is in Aurora, you're going to see you only get these 2 options. There's no free tier option in Aurora. So you can select a free tier, but if you select free tier, then the multi-AZ options are going to disappear for you. Like if you were going to try to replicate what we had before with a MySQL master slave and 2 different AZs, you would have to select this one. Availability and durability, these 3 options are available. You can click more info for here. The biggest difference is this multi-AZ DB instance. The DB instance doesn't support read workloads. So if you wanted to have that master slave with a read replica, then you're going to have to go with the DB cluster. Then you can select the ID for it. You can set the username and password. You can self-manage it. We're not going to fill that in. Down here, you can select the instance type based upon your application and how much demand and resources you're going to need. You can size the instance. And then you can also size the amount of storage and the storage speed. Connectivity, we're going to go through these in detail when we do the Aurora instance, so we won't spend too much time here. And then I think that everything else is kind of the same when you select Aurora. Let's go ahead and go back to the top, and we'll actually fill this out for real, and we'll deploy an Aurora instance. One of the biggest differences between MySQL and Aurora is Amazon has spent some time with the Aurora engine and fine-tuning it so you can see the kind of the performance improvements over here. We're just going to use the default version here. And here's where you can see that that free tier is no longer available. We're going to go with the production tier. We're going to go ahead and name this. We're going to switch it over to just our root, self-managed, so we can enter a password here. Storage options, again, this is depending upon your needs, and you can select info here for more information and read through kind of all the details. I'm just going to keep it at the Aurora standard for our case. For the instance configuration, I'm going to go ahead and do the burstable T classes because I know that that's going to be a little less expensive for just our demonstration purposes here. But again, you would select the instance based upon your application needs. We are going to do the multi-AZ deployment. One of the things that you'll find with the multi-AZ deployment for a cluster for MySQL is you'll actually need 3 subnets. Our current VPC only has 2 subnets, so you'd have to add a 3rd subnet to actually make that work. That's one advantage of using Aurora is you only need 2 subnets. For connectivity, there is this connect to EC2 instance, and if you select this, you're going to be able to select your EC2 instance. We're going to do the other option and manually add an EC2 instance later on. So we'll show you how that's done. For the VPC, we're going to deploy it to our Laravel demo VPC. And I'm going to use the subnets that's selected. The VPC that is currently selected is the same one that we had before. I did have a 3rd availability zone because I wanted to see how the MySQL version worked, and that's how I found out that you really need 3 subnets. Right now, this is in 3 availability zones and 3 subnets, but we're really going to only deploy to those 2 that we need. We're not going to have a public IP address. We're going to allow it to just kind of do the default ones there. The Proxy is something you probably want to consider if you have a lot of connections to the database, because that way there can be some connection pooling going on. We're not going to use it for this case. I'm going to leave this option off just so it behaves kind of like what we had before, so that there really only is one write endpoint. And everything else, I think we're going to leave it the same. For monitoring, maybe we can tick it up to maybe 1 per second. And my estimated monthly costs are about $60 a month for this configuration. I chose the least expensive option, which is in the T series. But again, for your application, you probably would not choose the least expensive option. You would choose the most appropriate option. So we're going to create this database. Amazon is promoting its add-ons here. And again, this RDS proxy, you probably want to use something like that just for the connection pooling options there. But we're going to not elect any of these options. Okay, so now you can see the Aurora database. It's spinning up and it's creating the instances. So we'll just give this some time and we'll let this finish up and we'll get back to it when it's finished. Okay, so we're back and the RDS instance is fully available. And you can see it's deployed in a cluster, and there's a writer instance deployed over to US East 1B, and there's a reader instance deployed over to US East 1A. So if we just scroll down here and we start to look at some of the things that are available to us, under connectivity, we can see our endpoints. We have a writer endpoint, we have a reader endpoint. We'll test both those in a little bit with our Laravel application. You can add some security rules if you need to. It looks like you can share this cluster, but I want to get to this part here where we connect compute resources. So we have this EC2 instance that has our application running in it, and we need to be able to set the security groups up so that this can connect to our RDS instance. This wizard is going to help us kind of set those connections up. We're going to go ahead and select Setup EC2 Connection. The database is already pre-selected for us, but here we'll be able to select our EC2 instance that we want to have connection to. Or if you wanted, it looks like you could create a new instance here, but we're not going to do that. So we're going to continue. And now we're going to review and confirm what's being done. So it's telling us it's going to create a couple of security groups and add it to one of them to the RDS, and the other security group is going to add to the EC2 instance. That way they can communicate with each other. There's no real options to select here, so at the end we're just essentially going to click Setup. And at the very top you can see the connection was successfully set up. So if we go back into our database instance and we scroll back down, here we have an EC2 instance that's connected. So I got a terminal window open. I'm on my desktop on my Mac here. And inside this directory that we're in, you can see the PEM file. So we've connected a lot of times before in past videos. We're going to do the same thing again. It's the Ubuntu user that's the IP address of the application EC2 instance. So we're going to go and connect into there. Once we're in, we're going to switch over to our deployment user, which is called demo_1. And then from here, we're going to go into the deployments directory. And the deployment user and all the deployment directory information, that was all covered in past videos. So I'm not going to spend a lot of detail here, but the most important thing that we want to do is we want to edit the .env file for our Laravel application. So here's our .env file, and we're going to scroll down to where we can find the database. And right now you can see that there's two endpoints. There's a write and a read endpoint, and they're both set to local hosts. So we are going to modify these. I'm going to grab the read one first. So we'll scroll back up to where the endpoints were, and we want the reader. So we're going to copy this one, and we're going to paste it into our window. And then we're going to go up to the writer, and we're going to grab the writer endpoint, which is this top one. And we're going to paste it in. So at this point, we should be configured for the endpoints. So this demo_1 database user and this demo_1 database do not exist yet. So we still need to be able to create those. But we're going to go ahead and exit out of here. And we'll save those changes. So to create our database and our database user for this particular deployment, we're going to have to use our admin password and our admin user. So the admin user was root, and the password we actually typed in when we created this instance. We're going to use the writer endpoint here, so I'm going to go ahead and just copy this again. So we're going to go back to the terminal. I still have this demo_1 session. I'm going to exit out of this session. So now I'm back to my Ubuntu session. So we're going to use the MySQL application, and we're going to remotely connect over to our instance here. So the user was root. We're going to have it ask for a password. .h is going to be the host, and we're going to paste in our writer endpoint. We'll type in the password that we used when we created that instance. And now we're into MySQL. So this is MySQL on that database cluster. We're on the writer node. So we've done this a few times in the past. So I'm just going to copy the SQL that we need over. That first SQL statement created the database called demo_1. Looks like I messed up the pasting a little bit. I pasted this line in there again. I ran it twice, but it doesn't matter because it says create database if not exists. So it didn't create two, and it wouldn't have created two anyways. But this is the line that we're interested in next, is the demo_1 user. This % allows it all remote connections. We're going to create this user. This next line is grant privileges on our database demo_1 for all privileges to that user. And then finally, we're going to flush those privileges so that they become active. And we're going to exit out of this. So at this point, our Laravel application, it has its read and write endpoints pointed to the RDS instance that we just built. The RDS instance has a database called demo_1 and a demo_1 user that we should now be able to use to connect. So let's go ahead and test that connection. We can test that connection using MySQL again. And we'll say our demo_1 user. And we have our endpoint. And now we're in. That user does indeed exist. So we didn't copy any data into our new database. We just start in fresh, blank database. There's no tables in there right now. So we do have to do our migrations. So let's get back into our deployment user. So we will use demo1 for this. And we are going to get back into that deployments directory. Just as a reminder, this symlink current points to the current release. So we're going to get into that one. And here you can see that we're a standard Laravel directory structure. In particular, we should have PHP Artisan available to us, and we're going to run PHP Artisan migrate. And our connection is working. We've created all our database tables. We're going to go ahead and seed our database with some data. So at this point, our database has some data in it. Okay, so we got our Laravel application back up here. So if everything's working correctly, we should be able to refresh this and we'll get a new data set here. And you can see that that is indeed functioning. All right, and as one final test, we're going to do a little bit of load testing. We did this last time when we did the self-hosted MySQL. We'll do the same thing here. We can't really use htop or glances like we did on our database instances last time, but Amazon does supply us some monitoring through kind of a monitoring tab right here. So what we're going to do is we're going to scroll down to the monitoring. There's like 9 pages of metrics that you get to monitor, and I think we're just going to search by maybe CPU so we can see CPU and maybe CPU utilization. Okay, so for our load testing, I think this is the best arrangement for Windows that I have. So I've got the RDS control panel up in here, and I've got on monitoring, and I have a filter for CPU. So we have all the CPU instances down here. I've set this so that it's gonna maybe update once every second. I kind of think these things are cached a little bit. I don't really think that they're coming in live, but you can see the monitoring down here. So what we're looking at is a CPU utilization on that managed database tier. And because this is managed for us, doesn't mean that we shouldn't monitor certain metrics. Depending upon the instance size and storage, you may run into some constraints where you're kind of hitting the limits of what you've selected, and you may need to scale this up or scale this out. So we're going to monitor CPU utilization for this test. And then over here, I have glances running. We can see what's happening on our application server. So the EC2 instance that's hosting the application, you can see it's bounding up to 37%, back down to 5%. I still think that there's bots that are hitting the endpoint every once in a while. It's been online for 16 days again, so I'm sure that bots have discovered this thing. When it's at the low point, most of this is from glances. There is some PHP background, so there's always like PHP Artisan happening. But when we start our load test, this will ramp up to about 100%. So what we're going to do is we're going to use the same load tester that we did before, and I'll start a new test. Once the test is started, we'll see the CPU here bound up to about 100%, and then we will go over to the RDS monitoring and see what we can see. I'm not sure we're going to see anything here. I don't think it's coming in kind of live, so it's kind of a little bit of a delay. So we'll see what we can see though. So let's kick off the test. And so now you can see that the test is running, and our CPU for our application tier is bounding up to 100%. Again, this is all PHP FPM. We'll work on scaling the web application in some future videos. But let's go over and see what our database tier is doing. I don't think that we're going to get a lot of new data coming in quickly. Is there a refresh button? Looks like there's a refresh button. This test will last about a minute, so at some point we should see a little blip. So our test has completed. Give this a couple more minutes to see if our data eventually arrives over here on the server. Okay, so it looks like we've got our little blip arriving right here. Let's see if we can zoom. We can zoom into this. So it's hovering here before the test at about 12.3%. During the test, it ramped up to 18 to 20%. So this East 1A is our reader. This is our writer. We don't have any writing really going on, but if you remember the last time we set Laravel up so that it could write or read to that writer node. So it will use them both as kind of a reader node. So it'll balance the request between them both for reading, but then for writing, it's only going to use one of the nodes. When it was doing the test for reading, it was using them both. So we are able to see something there. So before we leave, this is the infrastructure that we just deployed. We have a clustered deployment of Amazon RDS Aurora running across 2 availability zones. We have one write node and one read node. Laravel is set up in our application tier to actually read from both of these nodes. It actually will load balance its read requests between both of them. Then it's also set up so that it only writes to this node here. And so that concludes kind of our database scaling options. We went through both a self-hosted option where we deployed MySQL on a master-slave combination using EC2 instances. And then we also looked at Amazon AWS's managed solutions. So we still have a few more videos coming up in this series. So it's probably going to be one video on scaling the cache. So right now we're using Redis. It's deployed in our application tier. And we'll probably split that off and use maybe Elastic Cache from Amazon as an option for that. And then we'll start talking about scaling the workers in the web. If you enjoy content like this, do me a favor, like and subscribe.